Let's consider log where our argument is 0. Is there ever a case where we can multiply 3 a certain number of times to get to 0? Because this is what log means. The only case where this would make sense is if the base were 0, because 0 times 0 is 0. And in that case, it would be hard to talk about what the log of base 0 of 0 is, because how many times does 0 multiply together to get 0? I mean, the answer would be anything. But we don't work with base 0. It doesn't really make sense. So we just can't find log of 0. When plugging in a number doesn't make sense, we say it's not in the domain of that function. Let's look at the exponential function. Log of 0 was undefined because you can't multiply a non-zero number any number of times to get 0. So this means that we can never input anything into b to the x to get a 0. So while 0 is not in the domain of log, it isn't in the range of 3 to the x. Let's think about other numbers we might try to put in. We know we can't plug in 0. Let's try negative numbers, and let's just use 3 as the base to make it easier to follow. To figure out log, it's easier to think of the exponent equivalent. How many times do we need to multiply 3 to get to a negative? Forget the 3. Can we ever multiply a positive number over and over to get a negative? No, that's not going to happen. So we can't have a negative here either. This would only make sense if our base was negative. But as I discussed in another video over the exponential functions, we don't do that. What does that mean? If we will never get that value back from plugging in any number, it means it is not in the range. So negative values are not in the range of b to the x. But if there's no way we can ever multiply any number to get a negative, that means we can never input negative numbers into log. So negative numbers are not in the domain of log. Are you seeing the pattern yet? How is the domain of log related to the range of the exponential function? So now we have settled that we can only have positive numbers greater than 0 for the domain of log, and the same positive numbers greater than 0 for the range of exponential functions. So the question now is, can we just put any number as long as it's greater than 0? What can we plug in here? Or in other words, what values can I get from multiplying a number together over and over again? Can we put in a 1? How will we get a 1 from our exponent? In another video, I already covered that a 0 exponent will give me the answer of 1. So 1 is both in the domain of log and in the range of exponential function. What if we have a fraction to input? Can we ever get fractions from an exponent? And the answer is yes. We get that by using negative exponents. I covered this topic in another video. What about irrational numbers, like pi? This is more difficult because it's hard to answer that question. How many times do I need to multiply a number to get pi? So I'm just going to kind of give a pictorial meaning. Some theory tells us that if we have a graph like this that is continuously drawn, and if we know that we have an x where 2 to the x is 1, and an x where 2 to the x is 4, well, pi is somewhere in between 1 and 4 because it starts with 3.14. So 2 to the x will equal every value in between 1 and 4 at some x. So we know that there is some x where 2 to the x will be pi, which means pi is in the domain of log and the range of 2 to the x. But the 2 is not special here, and it is true for any base. And we can make that argument not just for pi, but any number greater than 0. So what we have figured out today, the domain of log is any number greater than 0, and the range of b to the x is any number greater than 0. And notice the domain of log is the range of the exponential function, and vice versa. So what do you think the range of log would be? And how would that relate to the exponential function?